Okay, then let me go back to model 1, okay, in which there are three regressors: interception, Korean interest rate, and US interest rate. This model is based on, as you know, UIRP. And according to the purchasing power parity condition, we say usually PPP condition, the inflation rates across countries also can be an important factors, important predictors. So right. So then that's why I just added a new data. Okay, let me open it. And of course, I'm going to post this on the Blackboard as well. Okay, here now we have 5 columns. Now the fourth and fifth columns are Korea CPI inflation and US CPI inflation rate respectively. Okay, then right. So then, based on this idea, I'm going to consider more regressors. Of course, inflation rates, right? So then, okay, now this is not T, B, C, D, E, F, F, right? F, right? So then, these are interest rates, right? Second and third are interest rate. But now we have the 4 regressors in this example. Okay, from the second to fifth columns. Okay, and then there is nothing to change. So of course these are not interest rate. That's simply interest rates and inflation rates, and interest rates and inflation rates, right? Okay, then here nothing to change, right? Nothing to change, nothing to change. Of course, this is 5 by 1, of course, right? And then first, second, okay, let me add more. Yeah, I see. These say, right? Okay, let me say this. Just INF inflation rates. Inflation rates are what? X colon 3 colon 4, right? So these are inflation rates, right, across countries, right? So that inflation rates. Is there anything to change? Let's see. Nothing, right? Nothing to change. Nothing to change in this line. What about this? Yeah, of course nothing, right? Because this is about dependent variable, right? Then what about this? X now has 5 columns, right? But this code is still general, right? Nothing to change. Nothing to change. Here, of course, this function is also the generic, so nothing to change. What about this? Yeah, nothing to change. Error. Okay, here. Okay, so once you specify the regressors and of course SKT1, right? Then it's done. Nothing to change, right? Particularly after this line, right? Because this part is so general. Okay, it can be used for any number of regressors, right? Okay, so then let me run this. Okay, I hope it runs well. So far so good. Yeah, it runs well, right? Okay, let's see the results, right? The first is Korean interest rate. Second, the US interest rate. the third one, Korea inflation rate, and fourth is the US inflation rate. This is Korea inflation rate, the US inflation rates. And then you see that this positive means are here, but we can't say these are big or small. We have to check the credibility intervals. And you see that credibility intervals are very large, right? Very large. Which means what? These estimates are not quite precise, right? These estimates are not quite reliable. This is positive and here is negative, but we can't simply say that the Korean inflation has negative impact on depreciation rate, because the credibility intervals includes both negative values and positive values. And same for the effect of the US inflation rates, right? Okay. So then, what about this? Log PPT, predictive accuracy. Predictive accuracy has it been improved or not? It looks worse than before, right? Because previously it was about minus 2.5, and now it's minus 2.6. Why it happens? Because maybe we have too many irrelevant, unimportant regressors like inflation rates, right? So the more regressors do not necessarily imply the more information. Okay, this is too much information. Okay, this is too much information. If we have too much information, the forecasting becomes less efficient. Okay, which means that this predictive density accuracy becomes worse. Okay, so the more regressors does not necessarily gives the more accurate forecast, right? So only when we have only important or relevant regressors, then finally we can have the most accurate density forecast, right? Okay, so here let me check this code again. Right. Okay. Then now let me try with let me extend the model 2 this time. Okay. In model 2 still A, B, C, D, E, F, right? The same as before. Now X0 is 2:2, 5, right? And then this is okay. This is okay. What about this? What about this? No, this is not okay actually. This is our interest rate differential, and we should have what? We should have inflation rates. Where are they? They are here. Here. The third and fourth column. Right? Third and fourth column. Okay, this must be semicolon, and it should be transpose. Why? Because this is 1 by 1. Okay, this is 1 by 1. This should be 2 by 1. Right? Without this transpose, this is 1 by 2. That's why I have transpose. Right? So then 1 by 1, 2 by 1. So this is now 3 by 1. 3 by 1, and now this is 4 by 1. Of course, this is 4 by 1 now, right? And then the regressors here. Okay, let me put this regressors, inflation rates. Inflation rates is what? Oops. X. Okay, colon, third and fourth column. And let me put this here, inflation rates, right? Now this is the new regressor, right? Okay, now we have 4 columns in X, right? 4 columns in X. Yeah, nothing to change, nothing to change. Of course, nothing changed beyond this, right? And then I'm gonna run it. Run. Yeah, it's worse again. So then still this is negative and positive, right? Then credible intervals have both negative and positive values. But in this case, now the impact of U.S. inflation rates seems to be positive, right? Because credibility intervals are all positive, right? So then we can say the impact of U.S. interest rate is positive, but quantitatively it can be around 0.13 or 0.12, 0.2, 0.3, 0.4, or 1.1, 1.2 like this. On average, it's 0.7, right? Despite that, its predictive accuracy becomes worse. Maybe we have the irrelevant regressors like this. Okay, and this one maybe, right? This one maybe. Okay, so then what if you wanna remove this third regressor? What can you do? Okay, how can you do this? So you don't wanna consider this third regressor, which is what? I think this is what? Intercept term, interest rate differential, and Korea inflation rate. So that of course you can just remove the Korea inflation rate from this, right? So then you can consider only fourth column of X. That's one way. Then you will have to change this line too, right? Maybe this line, maybe, I don't know. Yeah. And another way is to change your prior, right? So then this one, first, second, third one, right? So then removing the third regressor means the coefficient on the third regressor is 0, right? So then I'm going to put very strong prior for the third regressor, B0. Third means 3,3. 3,3 is 0.0000001. Okay. Then just okay, discarding the third regressor. Okay, and let me try. Yeah, that's much. Anyway, this is very close to 0. Okay, very close to 0, right? And what about this? The first one. First one. Maybe. I don't know. Yeah. Okay. So then maybe you can remove the first one, or maybe the second one as well. like this, right? So then in this example, we have only 3 regressors except the interceptor, right? So then you have to try all different combinations to improve your predictive accuracy, right? This is really computationally expensive and tedious, right? Right? So then, but what if we have more regressors, right? Like 10 or 12 regressors? It's not easy. It's going to be very, it's going to be, it's going to be a lot of work, right? There are too many combinations, right? And but this is very common. Just think of inflation, and dependent variable is now inflation. Okay, what kind of predictors, what kind of regressors can you think, or can you consider? All partial macroeconomics, all partial macroeconomic variables, right? Is there any macroeconomic variable that does not affect inflation rates? It's really hard to find. Okay, can you can you can you imagine any macroeconomic variables that do not affect GDP growth rate? Of course not, right? It's not easy because all macro variables, including exchange rates, are determined jointly or simultaneously, right? So there are strong interactions among the macroeconomic variables. But this is true theoretically. But empirically there are only a few, very small number of relevant regressors, right? So then the next time we are going to learn how to choose important regressors only among many possibly relevant regressors. Okay, this is the core of machine learning. Do you know the definition of machine learning? Definition of machine learning is very simple. Machine learning is dimension reduction. Okay, just which means just extract a few numbers from a few important numbers from tons of regressors or tons of informations, right? Okay, so then next time we are going to learn the core of machine learning. Okay, we are going to let machine select relevant regressors to improve the predictive accuracy, right? Okay, so we are done today.